electrostatics. So as a quick recap on electrostatics, I want us to look into where we started everything else. We first spoke about now charge quantization. This is now Q nu is equals to Q1 plus Q2 over 2. And then thereafter we spoke about now charge transfer. And then immediately after charge transfer, we spoke about now how to go about calculating the number of electrons. But now this, I'm only doing it as a recap such that now we are able to charge transfer, and thereafter we spoke about now the number of electrons. So the number of electrons, we said N is equals to Q over QE. And then now at number 4, we spoke of Coulomb's law. And we related now Coulomb's law with Newton's third law. So I want to break down for the session of today. For the purpose of today, we said we are going to have now charges in 1D, and now we are going to have charges in 2D. So this is what I want us now to look into in detail. Remember, we still said we also have now the fifth one, which will be our electric field. But our electric field, we will do it now once we are happy with now Coulomb's law in terms of charges in 1D and charges now in 2D. And remember, we said for a maximum of 3 charges, and also this side it will be now for a maximum of 3 charges. So this is where I'm going now to start. The last session we spoke about 1D. So today, as an introductory part, before we can do a few particular problems, I will start now with explaining 2D charges. So now I think this should be our number 7. Now charges in 2 dimensions. Charges in 2D. Now, when you work with charges in 2D, hint number 1 is the center charge. The center charge, or the charge at the center. Let's write it nice to say the charge at the center. The charge at the center will always be your reference charge. So the charge at the center will always be a reference charge. A reference charge. Remember, when we're working with now charges in 1D, we said now a specific charge will be given now as a reference. But now when we work with the charges that are now in 2 dimensions, it's always the case that now the center charge will always be our reference charge. So in this case, they will not tell me to say, calculate now the net force experienced by this specific charge. They will not specifically indicate which charge is a reference charge. The reason for that is the center charge will always be a reference charge. So if this is the case, then it says for the very same charge or for the very same situation, I must be able now to draw a free body diagram for all forces acting on the center charge. Then now measure, or let's say now firstly calculate acting on a center charge then immediately after drawing a free body diagram, then you'll be now in a position of calculating each force acting on the specific charge. So the center charge we calculate or even draw. Thereafter now use F is equals to K Q1 Q2 over R squared now for each force. But now here comes the challenge now. If this is the situation, then it means I must first now be in a position of saying, if, as a form of example, that if I have Q1 and now I have Q2 and I have Q3 forming an angle of 90 degrees. Forming an angle of 90 degrees with each other. So what do I know? I know that now this one here at the center will be my reference charge. So I must just maybe indicate also the charges on each, and indicating the charges on each, I will say Q1 is negative, Q2 is positive, and then Q3 is also now positive. So if I am going to draw a free body diagram now for forces acting on Q2, it is going to be what will be the influence of Q1 on Q2. Between Q1 and Q2, I have an attraction force. So it basically says now Q2 will move towards Q1. So I'm going to have a force. Let me use a ruler for the purpose of straight lines. So I'm going to have a force in this direction. And this force now we call it F of 1 on 2. And I'm going now to have between Q2 and Q3, it's repulsion. So I'm going to have another force now that moves in this particular direction. And this force is a force now of F3 on 2. Let me not forget my arrows because now they are very, very important. But I can easily see that now they are forming an angle of 90 degrees. So if they are forming an angle of 90 degrees, this is exactly what informs me to say now the arrangement, it is now in 2 dimension. And if it is in 2 dimension, then for me to get my net force, I must have now a line there. This line definitely now indicates my F net. But now, measuring Fnet, that is very, very key. We will always have this angle here, theta. So measuring the direction of Fnet, use now tan theta is equals to f of y over now f of x. If I remember it well, that's how it should be. So that will give us now the angle. But I must emphasize theta will always be between 0 and 90. So it basically says I am going now to look into the quadrant at which now I find my Fnet. So my Fnet will always now be measured from x-axis to where now Fnet is. So we are going to measure always now from the x-axis. So it will be greater than 0, but now less than 90. But now what if I find that now my angle is in a position of which the quadrant it's not in the range of 0 and 90? That is now very, very important. Let me have my Cartesian plane here. Let me have my Cartesian plane, and then I will have my arrows as well. So now what I want us to be aware of is I have now north, I have west, east, and south. But remember, I always now measure from a position of now the x-axis and moving into the direction of where the Fnet is. So it's either I can get the Fnet into my first quadrant. If I get it on first quadrant, it's fine, because now in the first quadrant, which is now I think 1, 2, 3, 4 in terms of quadrants. If I get it in the first quadrant, it's fine, because now angle theta will be between 0 and 90 degrees. So in this case, you are not going to use bearings and that we did in vectors. We are just going to use simple mathematics for us to understand this fully. So if I'm in first quadrant, it basically says it's 0 and between 0 and 90. So I'm going to have now my angle in that particular direction. That is fine. But now if it starts jumping now into the second quadrant, I can only use now 180 minus. So this will be now 180 minus once now it starts being in the second quadrant. If it moves now to the third quadrant, then I'm going to have 180 plus. The reason why we do not use 90, if you are doing mathematics, remember, once you use 90, you are going now to get the inverse of tan, or tan now changes into cotangent. So we don't want that, because we are only focusing on working with tangent there. So if we want to work with tangent, it means we cannot use your conventional degrees, which is now 270 and 90. Once you do that, then the science becomes very wrong. So it says to me now, if this is the case, then in the fourth quadrant, I can have now 360 minus. So having the 360 minus will also allow me to do so. So the easiest thing is you can either work with the cardinal planes, which is north, west, south, and east. But now we need to be specific now to say exactly in which quadrant is that. So I will be always measuring for my x-axis. So if, for instance, if my F net was here, then measuring from this particular direction, it will be now east of north. And then I will be able to assign the number or the value of theta that I should have now calculated. So it's always important to check which quadrant are you working with. So once you work with that particular specific quadrant, everything becomes easy because you know that you'll always be measuring from x to Fnet. So in so doing, it will allow you now to be in a position of ensuring that everything is done the right way. So now I'm going to pause for the next 15 seconds such that I allow you now to digest this. And if there's something maybe that you want us to discuss in relation to this two dimension, because I think now we can see that we are going to calculate for f done by 3, 2, and then f done by 1, 2, and thereafter, because we want now Fnet, it means I can go back here and say after calculating for each, then I must use the Pythagoras to calculate. So I wanted now to say I will not be able to calculate or maybe show you the specific slide or add the use of Pythagoras theorem before I could exactly indicate why we need to use Pythagoras theorem. So I'm going to allow you to digest this for the next 15 seconds. Then if there are no questions, I will proceed. But I think maybe there is something that you want me to explain further, because this is basically it. There isn't anything much. So before I take hands, let me just run the clock down such that we know that everybody is digesting with us. Okay, Manuku.
Afternoon, sir.
Evening, Manuku.
Evening, yeah. So is it always going to be, will you always use the interval 0, that interval given there?
Okay, the interval, whatever
Yes,
you
sir.
calculate, regardless of the values you have for Fy and for Fx, you will always get the interval 0 to 90. Let me draw something quickly. Check your screen. Let me draw something quickly. Let's say I have my Fnet here. I calculated whichever value I have here. This is my free body diagram. And then I calculate this. So, but now can you see that Fnet, let's say this is f of y, and this is now my theta, and this is my Fnet. My point is, when you use tan, which is equals to Fy over Fx, you will always get this now as an acute angle. Let's say you get it now as 28 degrees. But now 28 degrees, it's not in the second quadrant. That is what I am saying. It's not in the second quadrant. So how can one be able to tell that if I want to explain to somebody to draw an F-net in the second quadrant, what is it now that I should be saying to this particular person? Because now in normal science, the 28 degrees is on the first quadrant, and that is not true. So how do we now adjust from having an acute angle and easily explaining that now, but by F-net, it's in the second quadrant? The first thing to do is you can have now your theta as 180 minus 28, which is equals to, let me get my calculator, 180 minus 28, it gives you 152. So when you get the 152, it's easy for one to tell where is the 152, because now we are measuring from 0 to exactly where F-net will be. I'm just going to say now it will be 152. So where is 152 degrees? 152 degrees is from here up to there. Then it means each and every one of us will be able now to draw the correct vector for F-net. Or one can say, okay, fine, but I got the 28 degrees when I was calculating this. But where is the 28 degrees? Let me remove this and use a different pen. The 28 degrees, it's here now. This is the 28 degrees we calculated from, this is west, this is south, this is east, this is now north. So one can say it's now 28 degrees west of north. Then it means now we are calculating from west to north. So we'll still be in a position of drawing the right vector. All I'm saying is, with use of tan, you will always get an angle that is between 0 and 90. But now 0 and 90, it's only on this side here. 0 on 90, the interval, it's only on this particular quadrant. So what if now we start moving on the second quadrant, the third quadrant, and the fourth quadrant? So if you're going to use the final answer of 28, then it means it's going to be wrong. Hence, I'm saying it is always best now to check which quadrant is your F-net. So if there's anyone who wants maybe to add on that, if it's clear, kindly indicate to me that it is definitely clear, because now we lose a mark also for not giving the correct direction. Manuku?
So, sir, can I ask again? Will there be a case where we'll find undefined because tan at 90 degrees is undefined?
Hence I said that if you start now working with 90, it means you are going to go for a cotangent, and we don't want that. So hence we be able now to say it should always be less than 90. Hence 90 is not included as well. And then we see Somakoba says it's clear. So I believe it's clear. Manuku?
Yes, sir, it's clear.
Thank you very much. Because if I wanted to include the 90, then it should have been 0, theta greater than 0, equal or less than 90. So the 90 is not included. I think I saw a hand up. Let me check who was it. I don't have hands, so it means now I can move further on. So guys, when I started, I said, yeah, Tenulo.
And that.
Yes.
Nka nna ka bua Sesotho ntate?
Tsenolo?
Ke re nka nna ka bua Sesotho ntate?
Can you not? Because now most of us here, we speak different languages, others will not understand. Kindly resort to English, Tsenolo. And Jerry, switch off your mic. Tsenolo, the platform is yours. Okay, ask yours in your Sesotho, I will translate.
Ntate kopa re kgutlele ho Cartesian plane yane ya 152 ntate ne kopa ho botsa hore ha re tla ho direction ntate re qala ka side le feng mo
Okay, tswela pele mme.
ne ke kopa ho botsa hore ntate ho direction ha re tla ho direction bo di north of west ha re ka sebedisa angle ena ya 152 degrees direction ya rona e tlo ba ntate.
All right. What she's asking is now for the angle of 152, where is it going to be? It's going to be from here. Let me use a brighter pen for you. Orange is going to be from here all the way to there. All the way to there. Because this will be our 0, this will be our 90, this will be our 180, and then moving forward just like that. So the reason for that is, remember, in vectors we have bearings. So in this case we don't want to use bearings because of having the cos of 90, having the tan of 90. So once you have a tan of 90, everything is going to be complex. So it's better off, remember, we always measure from the x-axis. So when we measure from the x-axis, my point should be, if I want to draw now Fnet for 150, I must now start measuring from east until now I reach the quadrant, which is now the one that has the 152. But one will be able to say, but now the angle I calculated and the free body diagram I drew, I know that now from the forces, this is the angle that is now 28 degrees. But now where is the 28 degrees? The 28 degrees, it's in the quadrant of now what? West of north. So it is just an easy interpretation of how to draw this. Because one will say, but now what if I calculate from Fy to Fnet? That is not correct. Because now calculating from Fy to Fnet, it basically says now you are now calculating from 90 to Fnet, of which is not what we want to allow. My emphasis here is whatever you calculate, you can go and check me on that. It will always be an acute angle. But acute angle, we find them now in what? In the first quadrant. So, but now my Fnet, it's not in the first quadrant. It's in the second quadrant. It is in the third quadrant, or even the fourth quadrant thereof. So I cannot be able to say, indeed, now this is how the situation should be. I'm going to allow other two hands. Busiso.
So, sir,
Yes.
I want to ask, if we don't say like it is 28 degrees west of north, can we see that it is 28 degrees measured from the negative x-axis in a clockwise direction?
100%. That is another option that I was going to write down. Let me write down quickly to say, it is now 28 degrees measured clockwise from negative x axis. That is what we are saying, as Busiso.
Yes, sir.
100%. So all I'm saying is, guys, there's a way of now interpreting the direction that is now given into us. You can either use now your x-axis, like Zbusiso is saying, 28 degrees, but where are we measuring it from? We are measuring it now from the negative x-axis. Happy with that? I am saying now, okay, fine. I know that now my tan here, or no, the angle here will always be between X and F net. So I know that I calculated this angle to be 28, but how did I measure it, or which quadrant? From west to north, hence now west of north. But somebody will say, but okay, fine. I don't want to use east-west negative axis. I want to use the real specific angle. With using the real specific angle, we'll now be measuring from 0 directly up to now 152. Then how do we write that one? We just say now it is now 152 because of, in science, our 0, it's sitting on our positive x-axis. I will give you 10 seconds to digest that, or 12 seconds for that matter. Okay, Tiamo?
Sir,
Yes, sir.
can I ask, using what Bushiso has proposed, how will I use using what Bushiso has proposed? How will I use the 152 degrees?
Okay, the 152. Can I have a new page here? Let me have a new page with a different free body diagram. Let me add a new page. Fine. Now, for the purpose of explanation, I don't know the charges and everything, but I'm just going to draw that I have now calculated or drew. This is my charge. I don't know what charge is it. And then I have, okay, let's use a different one. I want to explain this in detail because I was expecting it. It's one of the misconceptions we have. So I have this force, and I have this force now. Let me move it a little bit. This, and then I say this here is Q1. And then I have my F of 2 on 1, and then F of 3 on 1. I don't know what were the charges, but what I know is my F net will be here. So I can easily say, fine, I know this is now my F net. But now what I also know is the angle which will give me where the direction of F net is. It should always be measured from the x-axis. So I will say now this is basically my fx, and then this is now my fy. So this angle, guys, is the angle that I'd say regardless of what you do, regardless of the quadrant, it is going to be between 0 and 90. I repeat, regardless of the quadrant, this one is now in quadrant number 2. This one now it's in quadrant number 3. So regardless of quadrant, theta will always be between 0 and 90 degrees. So theta will always be an acute angle. But now we must write now the direction. We have calculated everything. We have used the Pythagoras theorem. Now the question is, how can I explain the direction now of F net? One can say, for argument's sake, we are going to say this now is 35 degrees. Calculating and everything else. So we must write our final answer. One will say theta because it is now in the third quadrant. Ne? So in the third quadrant, we use now 180 plus. So if it is in the third quadrant, it will give us 180 plus. So I'm going to write now the final answer. It is going to be 180 plus now 35 is equals to 180 plus 35 is equals to 215 degrees. So what does this basically say? I'm going to have this here. It basically says if we measure now from here to there, this should be 215 degrees. So we'll still be in a position of explaining or drawing the right direction of F net. But now somebody decides to say, no, I don't want to use 150 because in an exam now, I don't know where is my 180 plus. One decides to say, okay, fine. I am just going to say, taking now the direction of Sbusiso, we will say it is equals to 35 degrees, but measured from where? Measured from negative x-axis in an anti-clockwise direction. Still acceptable because you are measuring now from fx, which is negative, to F net, but you only measure the 35 degrees. Then comes now another way of giving the direction now to say, okay, fine, but now I want to explain in terms of the cardinal plane. That is now east, north, south, and west. So I will say now it is 35 degrees and then measured from west to south. So it is now 35 degrees west of south. All these are correct in terms of giving the direction. It's just an issue of preference. What is it that you understand more? What is it that you feel comfortable with? In an exam, we look now for all these three, but preferably we use now the first one. This is number 1, this is number 2, this is number 3. In an exam, preferably we use number 1 and number 3. But now if you are in a position of using number 3, I will still encourage you to do so. Just now be on the lookout to say if it's on the 4th quadrant and the first quadrant, then it must now change to positive x-axis. So I'm going to give you another 15 minutes for you to digest this, not 15 minutes, 15 seconds for you to digest this. I think I tried to explain in detail. And if there's still hands, I will take hands after the 15 seconds. Umpile.
Good evening, sir.
Good evening.
So, sir, for the first one doesn't have a direction.
Which one? The 215, okay?
Yes, sir.
No, the 215 is the direction. Remember, I said now our 0 in science will be here. Let me wait for the computer to respond. Our 0 will be on the positive x-axis. Then we have our 90 and our 180, and then we move anti-clockwise like that. So our 0 will be there, and then we'll have our 90, we'll have our 180. So basically the 215 is the direction. But when we only measure from where? From positive x-axis to wherever our F-net is.
Okay, thank you, sir.
Thank you. Because the rule is we always measure from the positive x-axis if we are going to use the first approach.
Okay, thank you, sir.
Thank you very much, Umpile. I believe, okay, let me check in the chat. It's Samuel. So will it not be easier if you say the aim is to find the bearing of F-net, which is the reason why we are using 150 instead of 28? Mr. Kamohelo Mahao, can I say I don't want to use bearings because now I'm going to confuse you even more. The only thing that I'm interested in is you now being in a position of fully understanding how to go about using the Cartesian plane in terms of quadrants, in terms of cardinal planes, as well as now the 180 plus, the 180 minus. With that being said, we treat now 2 dimension the same way as we treat 1 dimension. The only thing that changes now, which is now a new introduction to us, is we are going to have to use Pythagoras theorem. So the Pythagoras theorem, I believe all of us from grade 8, we should be aware of that. So once you use Pythagoras theorem, you will get now the value of F-net. But now remember F-net, the fact that it's a vector quantity, it must also have a direction also. So F-net is a vector, so it must have now direction as well as the magnitude. So this being said, it basically says, fine, this is how now you can calculate your direction thereof. So I explained with this example for you to have a clear understanding of how we go about it. Then now I moved to another example to say, after drawing everything else, your free body diagram, and you finally get this, then you now be able to use either the 3 methods that we spoke about in order for you to measure your angles and be able to interpret it, because one question that I met somewhere wanted you to draw the F-net, not necessarily calculate. So drawing the F-net, if it's given in terms of the multiple choice, then you should be able to assign now in terms of the direction thereof. So I have a nice question here as a basic question that I want us to look into and now explain. I'm going to give you a chance to write your answers in the chat, especially for 9.1, 9.2. So it is 3 marks. So I will give you something like, let's see, it's 3 marks. So let's give you something like a minute for you to do 9.1.1 and then 9.1.2. Just a minute for you to do that. Let's go. Don't forget to send your answers in the chat. Okay, fine. I saw your answers for 9.1, but I didn't get much of 9.12. So let me give you extra 10 seconds or 15 seconds for 1.2. For 9.12, I'm looking for 9.12 now. 9.1, I got your I don't see answers for 9.2, guys. 9.2, 9.2 will give you 30 seconds extra. 9.12, 9.12. And remember, I can choose anyone to explain. Thank you very much. I found answers. Now I'm going to read it quickly. It says now 2 identical spheres, P and Q, separated by a distance D, are suspended from an insulated rigid bar as shown in the diagram below. The charges on the spheres are -4 microcoulombs and now +8 microcoulombs. Now, the spheres experience an electrostatic force that we know. In which direction will Q move? Only to the left or to the right? So now, basically what they are saying here is I can draw now a free body diagram between Q2, okay, not Q2, being used now to numbers, and P. So it's attraction, so P will move in this direction and then Q into that direction. So this is F of P on Q, and then this is F now of Q on P. So it basically says if this is the case, then Q will move now to the left. So to the left must be now a correct answer for us. So now The spheres are now made to touch and then separate. So that is now quantization of charge. So if that's quantization of charge, let me write it here now at 9.12. For quantization of charge, how do I know they were made to touch and then separate? So it means I'm going to check now for my Q2. It doesn't say you should calculate. I'm only emphasizing in terms of what and how best can we be able to understand this. So it says now it will be Q1 plus Q2 divided by 2. This will be 4 minus plus 8 and then 2, and then this will give us 4 over 2, and then we get 2 microcoulombs, which is now positive. And what did we say? We said now if you are more positive, it means we have been removed now the electrons. So this being positive, it basically says now the net charge on P is positive. So if the net charge on P is positive, it means now the electrons has been removed. So because of this, we say now the net charge is positive. And remember, if the net charge is positive, it basically means now electrons are removed. Electrons are removed. So it basically says now we can be able to say the correct answer here should be removed from P, and the answer is that one, that the net charge on P is positive and excess positive electrons have been moved. So this is now the best way of doing it. So I'm going to give you also another minute or so. Let me make it 1 minute 30 seconds for us to calculate 9.13. So I'm going to make it a minute and 30 seconds. Thank you very much. If you didn't send your answer, and the common answer I see is 0.6, most of you got it very wrong. The reason for that is you did not understand the issue of quantization. Let me explain again. The key word here is the spheres are now made to touch. So once they are made to touch, it basically says there is now a different charge on both of them. So after touching, it says now I have here 2 microcoulomb, that is positive. This is the new charge. Hence, I calculated it now for you to say because they have touched and separated. So it basically means now Q is 2 microcoulomb and this one is also 2 microcoulomb. So because you did not use that is the reason why you get your answer as 0.6, others as 3.6. So the correct answer in this case should be 0.21 meter. So I'm going to try and duplicate this slide so that I can make space. And remove this. Now I know that I have new charges that I'm going to work with. That is now the most common mistakes that you guys do. So it basically says, if now you are in an exam, you made such a mistake for such an easy looking question, then automatically you have lost those marks. So the emphasis is, let's now try to fully read the question and understand it fully. So 9.13, the new charge here is F net. Okay, let's just say F. F is equals to K Q1 Q2 over T squared. So what is net force? 0.8. And then my proportionality constant, 9 multiplied by 10 to power 9. And then I'm going to have 2 multiplied by 10 to negative 6 multiplied by 2 multiplied by 10 to negative 6 divided by d squared. Then solving for d squared, I will get now 0.2121 meters. It looks like an easy question. Yes, it is. But what I wanted to emphasize with this particular question is now charge quantization, calculating the new charge after the spheres have now being together or they have touched. Because now if you use the -4 and the +4, definitely you are missing the concept. So I'm going to give you now again 15 more seconds for you to digest this. And then if you have questions, then you can raise your hands and then we'll move to another question. Thank you very much. I didn't get any questions. So it basically says we can now move to this particular question. Look into it. I'll give you exactly 9 minutes to answer everything. Okay, can even make it 10 minutes. 10 minutes is a lot. Okay, let's make it at least now 7 minutes. And then your 7 minutes starts now. And then share your answer for 17.3 in the chat. Then thank you very much. All the answers I got, nobody got it right. unfortunately, and that's very sad. So I will try and explain it bit by bit as we go through it. Then 7.12. Okay. Okay, 17.1. All of us should have got now 2 marks because it's a straight stating of the law. Ne? So this should be now an easy 2 marks. The law says the magnitude of the electrostatic force exerted by a 1 point charge on another point charge is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. 2 marks. Non-negotiable. It's just a law. It's a level 1 type of question. Each and every one of us should be able to answer. 17.2 needs me now to highlight and understand a few things. 2-point charges. 2-point charges P and S are placed a distance 0.1 meter apart. The charge on P is 1.5 multiplied by 10 to negative 9. That is, and that on S is negative 2 multiplied by 10 to negative 9. A 3rd point charge R with an unknown positive charge. Let's highlight that unknown positive charge. So I know that this is also, it's also positive. Is placed 0.2 meters to the right point of S as shown in the diagram below. So now I'm expected to draw a free body diagram. Now I have 3 forces. So it means I'm going to have my R here. And the question should be, what is the influence of, as Busiso, your answer is also not right. So thank you. So now, what will be the influence of P on R? It's plus plus, so it means now P will be pushing R away and R will move now towards the right. So I'm going to have R and a smaller than a force, which is now F of P on R. Because of now the distance between R and P, it's now 0.3 meters. Then I am going to have now the influence of S on R, which is just now 0.2 meters. But now S is negative, R is positive, so it's attraction. So it means R will move towards S. I'm going to make it a little bit longer to emphasize the issue that now this is S of R and the distance is small. Kamohelo Mahau, your answer is also not correct. And then Mapani Hope, your answer is also not correct. So I will explain where you are making mistakes, because now that is the reason why I'm here. So if you are getting them right, then it means you don't need me to be here. So you can easily see I am going to work with 2 forces like we previously said. But I further read now the question on 17.3. So reading the question on 17.3 says, calculate the magnitude of the charge R if it experiences now the net force of 1.7 multiplied by 10 to negative 6 to the left. Jerry, your answer is also okay. Your answer is correct, Jerry. But now let me explain now to everybody how we got to that. Remember, at 17.3, we said once we have forces in charges in 3 dimensions or 2 forces, the best thing to do is now we should be in a position of saying we are going to use Coulomb's law 2 times. So I'm going to choose now this direction as positive for the purpose of calculating. Remember, I am working with now vectors here. So I'm going to say now, let's first calculate f of SR. So it basically K Q of S Q of R divided now by R squared. What will this be? 9 multiplied by 10 to power 9. Q of S, it's now multiplied by 10 minus 9. Q of R, it's now an unknown to me. Then divided by the distance between the two. The distance between the two is 0.2 squared. Then I can do the mathematics and say, I'm going now to have 9 multiplied by 10 to power 9, 2 multiplied by 10 to minus 9, QR divided now by 0.2 squared is just now 0.04. So I'm going to take it further and say 9 exponent 9 multiplied by 2 exponent minus 9 is equals to, divided by 0.04 is equals to, so I get f of R SR is equals to 450 QR. That is now my first step thereof. Then I further move now, I'm working now with f of PR. So f of PR will be Q of P, Q of R divided now by R squared. Then I have 9 multiplied by 10 to power 9. And then I am told is 1.5 multiplied by 10 to minus 9. And then I don't know what is QR. Then the distance between the two, 0.3 squared. So I'm just going to say 9 multiplied by 10 to power 9. 1.5 multiplied by 10 to minus 9. And then QR. So 0.3 squared, it's something like 0.09. Then divide all this, it's giving me something like 150 QR. Very good. So I have two equations here basically. I have this equation for working with f of SR, and this equation here working for f of PR. So because I have that, now I can introduce the issue of having the Fnet. We are told that Fnet is equals to 1.727 multiplied by 10 to negative 6 to the left. And then they say take forces directed to the right as positive. That is what we did. So it means I'm in a position now of saying, fine, the forces that are directed to the right, which is FPR or F of PR, then it must be the one that is positive. So I'm going to say Fnet is equals to F of PR plus now F of SR. Let me clean it up. SR. So now I can just issue the values. FPR is in the positive direction, so I must still write it as 150 QR. And then F of SR is in the negative direction, so it must be minus 450 QR. Then what is Fnet? They said Fnet, now it is to the left, and to the left is negative. So I'm going to have negative 1,27 multiplied by 10 to power of minus 6. But when I do the mathematics, this becomes easy. It's 150 minus 450. It's going to give me 300 QR. Minus 1,27 multiplied by 10 to minus 6. Divide now by negative 300. Divide by negative 300. And then you get now your QR as, let me punch into my calculator, 4,23 multiplied by 10 to negative 9 coulombs. So now this becomes my final answer, and now that becomes the value of QR. Hence, this was now 7 marks. So I'm going to allow hands. If there's something or somebody that needs further explanation, we'll put it somewhere here. Okay, let's put it here. And then I'm going to give you 40 seconds to digest and think of it. If there are hands, then show that, and then I will be able to attend to you. But most of you got it very wrong, and that is so sad. Okay, thank you very much. I didn't get any questions or hands or anything in the chat. So it basically says the explanation was clean and straightforward. So guys, this is type of questions you're going to come across in an exam. So it's just an issue of applying all the principles we spoke about. So the principles in terms of the questions will forever change, but the problem now is how best do you interpret the question thereof. So we have now 5 minutes left for this particular session. I have another question here that I want us to look into. But now this question, I think because of time, we will not be able to finish. It's also another exam type of a question. So let's agree to say I'm going to send the notes up to this particular question. Analyze the question, check how best can go about it. And then next week when we meet, then I will do the one in 2 dimension, and then we'll close off with the electric field. Then we will be done with this particular section. So I want you now to, let me wait for this to respond, show you something related to that question as well, just to show you the trend. And mind you, these questions are questions that were asked in grade 12 papers. Remember when I started, I said now this topic overlaps to grade 12. That's the reason why now I'm exposing you to this at this level, because already you are able to answer, you are able to do a few calculations. The intensity of now giving you how to approach this topic is very, very key for me, in a sense that now I'm preparing you for the future. So what I want you to check now on this question also. This is question 15. There isn't anything different to expect. It says now two small spheres as x and y carrying charges of plus 6 multiplied by 10 to negative 6 and now plus 8 to negative 6 respectively are placed 0.2 meters apart in the air. State Coulomb's law. So it's easy 2 marks that each and every one of us must be able to state. So if you don't want to state Coulomb's law, it basically says you don't want to be getting this particular marks. So please, it states the laws, the definitions are very, very key. And in most cases, there will always be 2 marks. Calculate the magnitude of the electrostatic force experienced by charge X. It becomes easy because it's just the application of Coulomb's law. Thereafter, a third sphere, that is where now the challenge comes. How do we work with the 3 spheres? So, and the 3 spheres are either arranged in a horizontal arrangement, or they are either arranged in what we call 1D. And now you can get another one arranged in 2D. So if you are able to do one arranged in horizontal arrangement and then the ones arranged in 2 dimensions, definitely we should be able to do well in our exams or tests. So please be on the lookout for this. We will do it next week. So when I send the notes today, it will only be up to this particular slide. So it is exactly 28 minutes or even 29 minutes after 8. So I'm going to set a timer for a minute for you to digest everything here. And then after the minute, I will definitely close the session. If you have any inputs, if you want to say something about this lesson, remember, it's for the purpose of the report. Kindly send them already now in the chat. If you want to comment about the session, the feedback, kindly send your comments into the chat. Thank you very much. And from me to you, all the best with the rest of the term. I know that most of you have started exams. If not, then all the best for that. And we take it one step at a time as it comes. So from me to you, thank you very much. So now I see Manuku says the lesson was good, but just tricky. Yes, it's the small things in the exam, in the interpretation of the questions that makes us now lose marks. So it basically says, let's read the question 2 to 3 times. Let's look now for the underlying factors. Let's look now for the signs thereof. So guys, from me to you, thank you very much and have a lovely evening.